Hi, this is Tim. Today we're going to add some diagnostics to our program to figure out that we have a device offline. In this video, we're going to be using our Compactlogix trainer, and we're coming from the lesson where we had just added the PowerFlex 525 into the I/O tree of the Compactlogix. And one thing I caution you of is pay really close attention to this I/O light. If it is flashing, even if it's flashing green, then something is wrong. We want a solid I/O light there. Now I say when it's solid, but honestly there's a lot of systems out there that it's not unusual to have an I/O light flashing on. Maybe it has some portable fixturing that's not always in place, or maybe, it's a big system and you may have something locked out from time to time to do maintenance or something and it's just offline. So what we're gonna do is we wanna make it where the blue light turns on if we have a fault with the drive. So we're gonna add another rung here. And then I'm just going to type GSV just to so you can do this. Just hit enter. And yeah, see, we got our instruction right over here. Now you can also find it right up here on the input output tab. There is GSV. And so it's going to ask for a class name, an instant name, and an attribute name. Now that can be really intimidating, but if we highlight this instruction and hit F1, we're going to get some great help on it. And if we scroll down mainly, we're going to get some indication of what these things are. But if we scroll all the way down, then we're going to see GSV, SSV objects. And that's going to tell us what all these options are. And we are going to be looking this time at module. And we're actually going to look at a lot of these later on. But mainly we have this entry status. And our entry status right here should be running, or 4,000. And that's what we're going to use to figure this out. So we're going to go back to our program. And so our class is going to be module. And our instance is going to be, where do we want to look at? So we're going to look at this drive. So it's right here. And then our attribute is going to be this entry status. We could also do the fault code, and actually we could do a lot of, this would be a nice one to play with, but all right, we're just going to do the entry status. And then we need to store it somewhere. So I'm going to call this trainer drive entry status. We'll create it, and it's going to default to a dent here. But if we actually go back, we see that entry status, the data type is actually an int. So we need to change that. So we're going to take our data type to an int, create. All right, let's go ahead and put that in and see what it does. All right, so it's showing a value of 16,384, which seems a little bit on the crazy side to me. So if we go back over here, we should be seeing values like 0, 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 9,000, and A00. And the issue is that we are actually looking at these in hex. So if we go back over here, let's right click it and go to monitor. And our default style is decimal. Let's change it to hex. All right, and now we see something that looks very similar. We see that 16 number and then 4,000. If we go back over here, then yeah, that is running. So let's go back and unplug. You saw for a split second we went to 5, and then we went to 1, and then 2, and then 3. But you're never going to see 4 in that. So 4,000 is where we need to be. And we can look up these other ones though. So 0 means it's standing by. 1 means it's faulted. 2 means it's validating. 3 means it's connected. But 4 is to where we've got to be. So we're going to do a comparison here. We're going to go ahead and add another rung right beneath it. And then I'm going to type NEQ, which is not equal to. And we're going to look at that trainer drive entry status. And the only thing that will work is 4,000. Now, here's a caution. Actually, let's do this the wrong way. is I'm going to type 4,000 in because that's kind of what you would think. And then I wanted to turn the blue light on. So let's go to our favorites tab, bring down an output energize, and we're going to go for local :1:0 .data.3. And let's go and put a description of it as the blue light. And put that into our PLC program. And all right, our blue light comes on because, yeah, my cable is unplugged. All right, we're going to plug our cable in. We're going to wait for this I/O light to go off. And, oh, it's still on. And this is because we entered that 4,000 as a decimal, but it is supposed to be a hex number. So there's two ways we can fix this. Is first, we know that, okay, right here, when we're running, it shows 16,384. We could simply put 16,384 right there, and that would work. And let's go ahead and do that, just so we see that it does work. Lights out, I unplug my drive, blue light comes on, telling us that, okay, we got a problem. I plug back in, blue light goes out, and that works. But here's my problem with that is when I'm troubleshooting later on and I look in here and I'm like, NEQ 16384, what does that number mean? And oh, I see the GSV here and I drill through all that. I'm never going to find a 16384. So here's where it is important that you put your units in something that later on you can figure out what the world they mean. And that probably comes more true when we talk about analog, because I see so many crazy scalings of analog, and it's like, all right, either make this thing a 4 to 20, make it read whatever its engineering units is, but so many of them end up in these crazy units. Well, we'll talk about that on an analog lesson. But all right, on this one, let's go back and edit this, and let's put in 16, and then the number sign, then 4000. Hit enter, you would first think, well, that's probably not going to work. That seems really jacked up. Well, this will work as we've entered it as a hex number this way. We'll put that in. Now it shows the same thing that we're going to see when we go over here and we're doing our troubleshooting. Works the same way too. So I unplug my Ethernet cable. We're going to get an alarm. I plug it back in and it goes back off. So there's a good way to signal that something is wrong with your connection to your Ethernet device. Now, a word of caution about these is that, I did that really quickly, and this isn't the way I normally would do it though, is these GSVs are right here, they can be more processor intensive. So I would actually either put this in a periodic task, or I would have some timer to throttle the amount that it's executed. And this was a bigger deal in older processors. And I don't know, let's look really quick here. Let's right click our main program. And we're running about, it's kind of jumping some there, but we're running around 12 milliseconds. Edit this GSV rung. And let's go over to our program control tab and bring down an AFI. And that's an always false input. And what it's going to mean is that this GSV is never going to execute. And let's put that in there. And go now to properties. Okay, and so it's taken it a few milliseconds to do that GSV. We were at around 11. We're somewhere around 8 or 9 now. So typically, I would say, we're not looking for an erratic problem here. Really, we're looking that the Ethernet device is offline. And I probably would just put that, really, you could execute that every few seconds. So, and let's go ahead and go through that just in case. So what I'm going to do now is I'm going to add another rung right above it. And we've made this timer before. We're going to make a timer that resets itself every time it becomes done. So let's go to our timer tab, bring down a TON, and this will be, let's just call it GSV timer. And create that. And we'll put a preset of 1,000 for 1 second. And then we're going to use on our favorites tab, we're going to bring down the examine off, and we're going to look at that GSV timer. .d end. And then we're going to go down to rung 3, and we're going to bring down an examine on of that timer. And what that's going to do is it's going to execute that GSV just once every second instead of continuously, just to kind of throttle back those GSVs that kind of are taxing on the processor. This will probably bring up an interesting question down in the comments is, doesn't this make our program scan continuously blip and be much longer than it should be? Well, absolutely does. And in future videos, we're going to talk about the different types of tasks and why, if you have a time-sensitive task, it probably shouldn't be in your main program. But really, okay, we've only really worked in the continuous task besides the PID series. So it was done in a periodic task because we wanted it done every so often. And actually, that may be what I would do, is I might create a periodic task of a low priority and put all the GSVs in it. I'm not sure how I would really do it. I'd have to think about it. It would depend on the particular application. But I definitely wouldn't have the GSVs continually doing it. But someone is going to ask, and they're right. You're right. We're going to have an 8 millisecond scan time and 12. 8 millisecond scan times, 12. And it's going to keep doing that. So that's maybe this will lead into a really good conversation about different types of tasks and how to deal with timing of them. So I hope this video has been helpful. That gives you another diagnostics tool to help you troubleshoot your systems. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!